I'm going to explain about the queue block. Queue is an abstract data structure somewhat similar to stacks. Unlike stacks, a queue is open at both the ends. One end is always used to insert data, which is called enqueue, and the other end is used to remove data, which is called dequeue. Queue follows two methodologies. The one is first in, first out, and the other is last in, first out. In the first in, first out, the data item that is stored first will be accessed first, whereas in the last in, first out methodology, the data item that is stored at last will be accessed first. Where are queues used? Actually, queues are used everywhere. Uh, if you want to be general, it is used in operating system, web servers, video games, etc. To be in specific, queues are used in BFS algorithm, that is breadth first search algorithm, whereas it helps in traversing a tree or graph. Queue is also used by operating systems for job scheduling. In networks, it is used to handle congestions. So, a queue is used in everything we do. In Visual Sim, queue is an important block. Basically, many blocks in the Visual Sim are built using multiple queue data structures. Queue block is used to define a queue that has an arbitration scheme to pop the next data structure out. We can also create multiple concurrent queues of type first in first out or last in first out. In queues, the delays are not predictable in advance. The data structures are also recorded based on the priorities of the incoming tasks in the priority queue. This block has 4 ports, 2 input ports and the 2 output ports. The first one is the input port for the data tokens or composite data structures that is entering into the queue. The second one is the pop input. This is the port that receives the queue number to pop the head of the particular queue. The next one is the output port, sending the head of the queue based on the pop port value. The last one is the reject output port. This port sends the rejected data structures out of the queue. There are certain parameters for the queue block. The first one is the block name. The block name should always be unique to the queue block. The next one is the queue number field. The queue number field selects the queue number to place the incoming data structure. This can be an expression, fixed value, parameters, etc. The next one is the priority field, which provides the priority number for reordering the queue. The next one is the maximum queue length, which gives the depth of the queue. The next one is the number of queues. Next is the initial queue state. There are two types of initial queue state, the first token flow through and the first token enqueue. If we select first token flow through, and the data structure will flow through every time the queue is empty and the last data structure has been acknowledged on the pop port. The first transaction of the model is always sent out. If we choose the first token enqueue, then one must provide the pop input to obtain the first data token or the data structure. So next one is the queue reject mechanism. There are two types. One is the incoming token rejected and other is the lowest priority token rejected. If we select the incoming token rejected and if the specific queue is full, then the incoming tokens will get rejected. If we select the lowest priority token rejected and if the incoming token, if the queue is full, then the lowest priority token will get rejected. The next one is the queue type. There are two types of the queue type. The first one is the first in first out and second is the last in first out. Single queue model. Here we have generated a traffic block with the value as 1 so that each packet will be sent out at an interval time of 1. We have a data structure of type header And then in this expression list, we have generated a priority field with random values from 1 to 5, and then it has been sent through the queue block. In this queue block, we have the maximum queue length as 5 and number of queue is 1. Since it is a single queue block, we have mentioned it as 1. It is of type first in first out. So then we have a constant block. This block is used to trigger the pop functionality. So we should mention this constant value should be always less than the this number of queues. If the constant value is greater than the number of queues, then it will throw error. So if this constant value is for say 2, which is greater than the number of queues, then it will throw error saying that invalid input value, the queue number should always be lesser than equal to the number of queues. So it should always be less than or equal to, so I'm placing the value as 1 again. So this will trigger the pop functionality so that the input will be sent through the output port if the constant triggers. So it will be sent through this text display. In this text display, we'll get all the outputs from the queue block. So let's check the output. So here we are getting all the packets. So we have the input rate as 1.0, that is it will be sent through interval of 1 second, and then the stimulation time is 10 seconds, so we are getting 10 output packets at an interval of 1 second each. Here you can notice that the packet came in at 9 second and left out at 9 seconds. We don't have any delay in this block. If we want delay, we can add the delay block, and we can also make this as a multiple queue. So let's see how to make that. So here we are adding the delay block, and by add we can um, add the value to the we can change the value of the delay value as execution length. In this expression list, now we are going to add the execution length field. So it is the random value from 1 to 1.5 seconds. So if we run this model, we are clearly getting delay in the tokens. That is, the queue in time is 1 second, and it's the queue out time is 1.3 seconds. So there is a delay in each of the tokens coming out of the queue. So here we have this field. This is the reject output field. So if there is queue overflow, or if there is no enough number of queues for the packets to come in, then it will be sent out through the reject output port. So to check that, before that we'll add the data time plotter for this queue. So I'll just add the expression list and the data time plotter just to plot the latency of each of the packets that's coming out. So here we can give the latency, that is the time that's coming out. Okay, so it's the data time plotter, and then to give that we can increase the number of packets by decreasing the input rate, that is the traffic rate, and then we can also change the queue length to 5 and the number of queues, let it be 3. So then if we run this model, we are getting the latency plot for each of the queue packets that's coming in. We can use the dots also, so that we can see each packet, the execution time of each packets. So then here also we can check. Okay, we'll just listen to this plot, this port. Okay, this is the rejected port. So if we run this model, here we can clearly notice that there are some packets that are coming out through the reject output port. Since there is no room in the queue, it's been rejected and sent out through the reject output port. We can see it's clearly coming in and there is no queue output. Okay, so then we can also notice that these packets are arranged based on the priority. Here we can see that the packet, the ID is 1, here 3, here 5, 7, and here 6. So the seventh packet is coming in, and then the sixth packet. See here, first the seventh packet is coming in. Sixth packet is coming in at 2.5 seconds. The seventh packet is coming in at 3 seconds. But first, the seventh packet is sent out at 63.76, and then the fifth packet. Because the priority of the seventh packet is 5, which is higher than the priority of the sixth packet, that is 2. So it is also sent out based on the priority value. That's all about the queue block. Thank you.